All right. Well, good evening, everyone. This was not planned, but I am also going to do a talk that relates to macros, but yeah, on the slightly more low-level, fiddly discussion, as opposed to a really awesome project that happens to use macros. So for those of you who don't know me, I'm Robert. I am a senior consultant at Alembic as well. A few of our co-workers are here tonight. And yes, I'm presenting using a live book, and there's a link here. I can message that as well to the meetup where the live book exists, and you can spin it up wherever, download it and spin it up somewhere, and have a play if you are so inclined. But yeah, I'm not using it much of the fancy stuff in live book, just the basics. So anyway, into the talk. So yeah, this is a kind of a glorified today I learned, based on some hair tearing that I put myself through working with macros when I don't really know what I'm doing. So just thought I'd put my thoughts together, and yeah, so it might be helpful for other people attacking macros to basically, yeah, here be dragons. So what are macros? Macros are the meta programming construct in Elixir, and the way you use them is through a macro called def macro. And so this code is actually from Elixir, the Elixir standard library, the kernel, def macro, so it's macros all the way down. Don't ask me how that works, but yes, it does. So yeah, def macro is a macro, and so is def module, all those kinds of things actually are macros. But the idea is that we can use macros in our code to do interesting things. So let's try out def macro. You call it a bit like declare a bit like a function, a variable x+1. When we run that, we get a module compiled. And this is the representation of a module, and it's exporting something called add1, and it takes one argument. And so we can call that. We can require the module that has the macro in it and run it, and we get 3. So okay, but I mean, isn't that just like functions? What if we do something a bit different and pass an expression to this add1 macro? Well, it's going to blow up. A bad argument, and it's a bit too detailed to explain why that's happening. But basically, macros are not really functions after all, and what their real interface is macros. When we say def macro, is they receive a set of quoted expressions in their arguments and return quoted expressions. So what is quoting? So quote is a special form in the Elixir compiler, which means it's very privileged, very deep down in the compiler. And when we call quote and put some Elixir code in there, we actually get some AST out, and Chu was showing quite a lot of this through his talk. And yeah, so this is the Elixir's abstract syntax tree, or AST, for the expression 1+1. And you can sort of tell that this looks like Elixir data structures, and you'd be right. So Elixir AST is defined in Elixir, and that's a property called homoiconicity, which is an interesting property in programming language theory, very prominent in your Lisp flavors of Lisp, where code is data and data is code. So yeah, if we look at a slightly more complex example where we're calling a function, we're mapping across some list that we've passed in. I mean, this probably doesn't actually compile. Maybe if I did that, there, that's better. Yeah, you can see a much more complicated AST is produced, but we can sort of see, we can see a little arrow here, and then there's a function. So here's our anonymous function. Here's the multiply and an x being our variable, and 2 being a constant, the 2 there, and there's x's. So you can sort of, if you squint, and you can see how it sort of maps together. So yeah, this is the currency that macros deal in, is these quoted expressions. But fortunately, we don't have to really think about them too much. So now that we know that we sort of need to use quote, we can go back to our example where we were trying to make a macro called add 1, which adds 1. So, okay, we need quote. So we'll quote this. Yeah, we get this warning. Variable X is unused. Warnings may not mean that our code is problematic. It might still run. So let's give it a go. But yes, so we tried to use it, and it says, yeah, this warning is cropped up again. X doesn't exist, and we get a compiler error, also saying that the variable X doesn't exist. So the problem in this case is that when we quote X plus 1, we just get, yeah, we literally get that back. So in this case, X plus 1 is not, or sorry, X itself is not a quoted expression. We're just using it as a literal variable name. And with just this code, there's no environment to get that from, and it couldn't get it from the environment anyway. So we need another special form called unquote. And what unquote does is it accepts quoted expressions and expands them. Well, that's the way I explain it anyway. So we've got an example here where if we take this some AST from earlier, the 1 plus 2, and unquote it, but then quote it again, we should get back what we put in. So remembering that quote takes something and turns it into AST, and then unquote does the opposite. So yeah, by quoting and unquoting and then quoting, we've done a round trip. But yeah, that's not that interesting. We can also see if we do that, what we get back out at the end. There's a macro.to string, and we get some, what we get 1 plus 2 out. So yeah, that's a little bit hand wavy. But yeah, suffice it to say, if you want to use variables, values from the outside, you need to unquote them inside your quote calls. So yeah, let's say we had X and Y as values, and we want to grab those variables and actually produce some code that's going to just put out 1 plus 2. This is how we would do it. We would unquote X and unquote Y and add them together there. And so we get, this is what we get out. So we've, rather than X and Y here, we've got 1 and 2. And doing the to string, we can see, yeah, we definitely get 1. We definitely get 1 and 2. And then putting all that back together, if we originally had wanted to do X plus 1 and whatever we pass into the macro actually evaluate that. Here's what the full thing looks like. We can compile that module, and then we can pass an expression in, and it does the right thing. It doesn't blow up like it did earlier. Remembering that earlier it said there was some kind of bad arithmetic expression, and it blew up. This time it's accepted 1 plus 1 as the value for x, has expanded that, and then added 1 and returned. So happy days. So that's kind of the real basics. How can we start using that? So one thing that we might want to do in an Elixir module is let's define some functions dynamically. And one way we can do that is sort of pepper our modules with functions defined elsewhere. And to do that, we can use a special, if we name our macro __ using, then one of the, then that macro can be used in another. And anyone who's used any amount of Elixir will have seen use. And so that's what's going on. Inside my macro module, we have a def macro __ using __. So if we want to, so far we've just seen code expressions inside our quotes, but we want to put functions, we want to define a function in the module that's using us. So naively, we could just say, okay, well, if I want to add one function on a module that uses this using example 1 module, just plop it in. But if we run that, the compiler says, no, you can't put def inside another function or macro. So what have we done wrong here? Well, of course, we need to, although it may not necessarily be obvious, and it certainly wasn't the first time that I tried to do this, that this needs to be quoted as well. So pretty much anything, ultimately, it's more that def doesn't return a quoted expression. So we need to quote that. So we use our trusty quote. And if we do that, okay, great. We've now got some AST back with no errors, and we can see what that's going to look like. And this is the code that will be injected into our module that's going to use our macro. Function called add1, and it's got an argument x. There's a new line in there, x plus 1. And then another line and end. So it's even sort of attempting to do some formatting for us. So if we put that all together, we can say, yes, we've got a macro module with using. We quote out a function add1, and use that in another module. And hopefully we now have a function called add1. Oops. And happy days. Add 1 to 5 gives us 6. So cool. How can we use this kind of stuff, the using and all the other macros quotes and unquotes that we've learned about? So there's an interesting example on the Elixir Lang website about how you would implement unless in yourself in a macro. So naively, if we wanted to produce an unless function that was kind of the opposite of if, we could have a module with just a function that does unless, takes some kind of clause or conditional, and then we do something. And what we're intending with this code is to, if the clause evaluates to false, then do this expression. So if I compile that, it compiles fine. But then if we try to use it, so in this example, we're saying unless false, unless true, then do this. So this output should never be printed, because it will it will invert this to be false, and so the do expression should never be run. But if we run this, we get that output. It's never printed. It is printed, sorry, even though it should never be printed. So something's gone wrong here. So the explanation is that in Elixir, function arguments are evaluated eagerly, as in that is before the function receiving the arguments is evaluated. I'm going to do some typo fixing as I go. So yes, the problem is that io.puts is evaluated before fun unless is. So regardless of what happens inside this function, we're going to get that output. So that's not great. If this is launch the missiles, then we've got a problem. So let's instead try using a macro. So instead of we have macro unless, and we pass it the same thing in here. And I think I have a bug there. Hopefully this still works. It still compiles. Yeah, okay. If not clause. Yeah. So yeah, okay. No, not to worry. This actually does work, even though I said it didn't, and that's because I have a bug. But let's continue on regardless, unless I've done something else wrong. No, that's all good. What we really need to do is so let's continue on. So yes, we need to quote. We have our and we still do the same call underneath. If not clause, then do expression. But we get some warnings if we do this. If we and saying that clause and expression don't are unused. Well, so they're here and we're using them. So what's going on? And yes, definitely, if we try to, again, warnings may not mean our code won't run, but yes, it's going to give us a compiler error. So what we did is we forgot, okay, we need our good old unquote again here. So if we, because if we look at what we get if we don't wrap unquote around our arguments, is we get expression and clause in positions in the AST. And yeah, don't you can just trust me that that's the case. These are just literal variable names, clause and expression. They're not going to be replaced with their values. And yeah, again, just to reiterate, we've got X in some outside variable being 2, but what we're going to get if we 1 plus X is literally the code 1 plus X. But whereas what we really wanted to print out is 1 plus 2. So what difference does unquoting make? So if we don't have unquote around X, this is the AST, but if we do have our unquote around X, then we will have a call to IO puts with an argument hello world in there. And so, yeah, this is what we want. We want to basically lift and shift this expression as is into here. And yeah, unquote is, as we've seen before, is how you do it. So if we bring that unquote back into our unless macro, we have unquote for the clause and unquote expression, and we run that one. It compiles fine, and this time it runs. And we indeed don't get, should never be printed. Change that. And well, it is printed at that time, but true is what we want it to be. All right, happy days. So yes, just to reiterate the difference between functions and macros, and why doing things like making your own conditional control flow, etc., is handy. Yeah, so function arguments are evaluated eagerly, whereas macro arguments aren't evaluated, but they're received as quoted expressions. So one of the big use cases for macros is busting boilerplate, is to reduce the amount of boilerplate, repeated code, etc. Making DSLs like formula. It's for example. So this is sort of the start of that journey towards building a library like formula is learning about macros and the not only making DSLs but just other ways that we might want to reduce boilerplate, automatically get code generated for us, etc. So one of the problems that I came across that I wanted to solve with macros, and it was a bit problematic, and I was questioning my sanity and whether I should be continuing down the path of macros, was I wanted to basically take some list of things and produce some functions with different implementations based on those things. So for example, I want to have a function defined called do action for each and a clause for each of the do action for each of these actions here, action 1, action 2. So what I can do here, because it's not clear, it's just this would be the same as what I want to achieve. Basically, is something like this. So I could write these out by hand, do action over and pattern match on action 1, do action, pattern match on action 2. But I know these values. I can put them in a list. Can I enumerate over them and produce a whole bunch of functions automatically? So naively, this is a first attempt. So if we evaluate that, we can see action is unused, that old chestnut. So we've seen that before. We probably forgot to unquote something. So let's unquote everything. So we unquote the action wherever we're using that. And I mean, there are other ways you could implement this so that you don't need to unquote that one, but that's beside the point. So we can compile that one. It seems to compile, but we've got some other fun. So just to highlight the problems as we go along, I've just added another non-loopy function that I want to define, and that one has been exported. But there's no do action in this. And if we, just to make sure, because who knows what this format really means. So maybe it is buried in there somewhere. We'll run it, but no, it doesn't exist. And there's this info function that you can call on a module to query certain things about it. If you pass in functions to it, it will tell you what functions are exported, some other fun, and the arity is the only thing that's exported. So yeah, that do action didn't happen, didn't even make it into our module here that is using our other macro. So what's going on? So it took me a while and lots of searching on the internet, but I did come to the realization that def macro it returns quoted AST. And like a function, it's going to return the value of the last expression. So all the things inside our def macro are still Elixir expressions. So in this case, this is our last expression. So that's why some other fun is in, but all this work we did up here just gets thrown away, basically. So we can say, okay, well, in that case, I will, rather than quoting each individual def do action and this one, some other fun, let's put a quote around all of them, see if that works. And you can already see that the compiler doesn't like it, and it doesn't compile. And it's saying that, it's, even though we've got unquote, it's still complaining that action doesn't exist. It's now complaining that action doesn't exist. And there's, it can't compile. So we had the unquotes inside the loop. So the unquotes here inside the map. Maybe somehow in this form we don't need unquote. That's my thinking. And so I tried various permutations of taking them out, and a different warning. This clause for do action cannot match because a previous clause always matches. And anyone who's ever done any kind of pattern matching and has got it wrong they've got inadvertently got some kind of catch-all clause for a function above one that takes some more specific arguments will have seen this this warning from the compiler. How would our two different def actions have the same argument? And thinking, well, without unquote, this action comes in literally. Okay, so we've just got two def actions with the argument literally action. So of course, if there's two of them, the compiler is going to complain about that. At this point, tried many other permutations, and then came to a realization by piecing Elixir forum posts together, etc., that if quote returns a value, we can assign it to a variable, and then maybe def macro will accept some kind of stitching together of that. So the easiest thing I thought of was just to shove them in a list. So here's the action functions assigned to a variable. Here's the other function assigned to a variable. We stitched them together with a list and give that a go. So if I compile that, it compiles, and do action now exists, and there's two of them. But that's something, and then we've got some other function. If we try to run them, we get some output. So action 1, action 2, and if we remember what we're doing is we're just taking whatever action, that's that atom there, and inspecting it and returning it. So that looks right. So wow, we've done it. And that took far too long for me to figure out how to do. And just to sort of double check, yes, we are indeed exporting action 1. Do action. So there's an interesting thing here. This list with another list inside of the do actions kind of looks a bit weird, because they're all supposed to be sort of top level declarations, or does is this how the AST works for this module structure works for multiple functions that have multiple clauses? Who knows? But so just as a little experiment, I thought, well, what happens if forgetting macros, we define some functions in a list, and normally from other languages, this wouldn't make any sense. We probably wouldn't compile, but in Elixir, it does. It just works. So if we compile that, we don't see this function foo and bar in this, but again, who knows what this format really means. But if we see what functions we're exporting for this funds, yeah, all three of them are in there, and then if we evaluate that, yeah, we get them all out. So that's kind of interesting that, yeah, you can define a set of functions in a list, and then another function, and the compiler still knows what to do with it. So yeah, maybe this form here is where we've got two do actions in a list, and then the other function. Maybe that's not so weird. And the reason for this formatting here, by the way, that tripped me up a bit when doing this presentation, is that Elixir likes to turn lists of pairs like that into format them as keyword lists, but they're all still the same form as that. Anyway, so it works. It's a little bit weird. There is a way of reducing the weirdness, even though it still works. There is a different type of unquote called unquote splicing, and rather than unquoting one and two, or treating one and two as a list together, it will expand them separately. And so, yeah, the code output is one and then two on another line, not in a list. And we can rearrange our macro module to unquote splice the action functions. So if we evaluate that, it still works, but we get this slightly more normalized form, I guess, and maybe it makes you sleep better at night. But yeah, kind of an interesting thing, but not required. It works either way. So almost at the end, another thing that I did take a little bit of time, but sort of knew intuitively from libraries, is that you can nest macros. So we can have a module that in its using has a quoted expression that uses another module, another macro. So this this module they're using for it is the one that produces our do actions. In this one, but in the outer one, or the where I'm using it, I'm sort of repeating the code again, but I'm calling it do action nested, and it's going to call do action. And then yeah, so the same sort of thing applies. We assign each of them as these quoted expressions to a variable, stitch them together, and we get sort of like a mix-in of a blend of all of them. So we've got do actions exported, we've got do action nested exported, and some other fun from our first macro and yet another. Sorry about the typo there. And yet another one. So, and it all plays nicely, and it plums all together. So if we call do action nested with action 1 and 2, it does the whatever code from the from our nested function, which is just to say that I'm in a nested function, and then it calls to the parent, so to speak, and happy days. And along those lines, not nesting anymore, but another thing that you can do, and the compiler just figures out, is if you want to have like catch-alls, putting them into the right order. So usually the compiler complains at you if you have function clauses for the same function out of order with others. So if you had do action, then some other function, and then other do action, it will complain. But this one just proves that the compiler behind the scenes doesn't actually care about that. It still compiles and it still runs. So so a few sort of very, I guess, corny casey kind of things that I learned, and in a quest to reduce some boilerplate. And which one is it? Using one macro inside the using of another. If you squint, this is starting to look a little bit OO, and I'm pretty sure in the early days of Elixir, lots of people tried to reinvent OO this way. And so, yes, I can see the appeal, because we had a use case where I learned all the stuff that was kind of like that. But you get to control how far you go along that path. If you just want to, yes, have some kind of child-parent relationship and do a bit of processing, common processing and specific processing, without inheriting all the baggage. The downside is that, yes, you have to learn all this macro stuff, and you can, it's a bit weird. So hopefully that is of some interest to people, but as they always do say in the community, macros are great and powerful and all that, but you have to go through a process to decide whether you want to use them, and that's the process. Basically don't use them. So again, that live book is up on GitHub, and that's all I had.
After you've all finished picking your minds off the floor and put back into your head, has anyone got any questions for Rob?
Given the silence, I just mentioned that 7.0 when Rob was saying what is that 7.0, the byte stream that he had there. That's actually the start of the Beam byte code, and that format is actually the IFF, the interchange file format that Electronic Arts, who made Marble Madness and all the early Star Wars games and stuff, they invented that in 1985, and that actually that's what Beam used. And that used to start with an FOR, capital FOR. That's what the 70, 79, 82 are in ASCII. But because the Beam file format's a slight superset of IFF, it's FOR1, which was the recommended extension for the IFF file format back then. And if you went on with that, if people went back and had a look at my Safeish talk from the start of last year, there'd be some more information about what that binary string actually is, and and there's a decompiler in the code if you wanted to look at how to decompile it into sort of logical byte code. Just a little aside. Sorry, it wasn't really a question, but if you're curious.
And you can find Robin's talk along with all of the other Elixir Australia talks on our YouTube channel. So please go and check it out, like and subscribe.
I have a question.
Sure.
I didn't really know, or I'd forgotten if I ever knew, what the rules were for the stuff after the binary that is the module compiles. is it a list and then it can contain other lists, keyword lists, or tuples of function names with arities? Is that the deal?
It's something like that. I mean, yeah, by purely by reverse engineering it based on looking at all these outputs, it's got to be something like that. But what the actual rules are, I don't know. Robin may know what that is afterwards. What the format for this? So that, I mean,
that one's actually that one is the it's the abstract code. It's actually like an abstract code tree, and it's what the debuggers use. And that's where I got that's if you want to look at the ISBN verifier, verily verified talk, which was before the Safeish talk, I actually go through what that format is a bit. And I was misled because that's how I got stuck on when I was doing Safeish. I thought that was the actual code. It's not the actual code that's interpreted. It's just like a nice to have thing that makes it easy. It's basically like pre-decompiled code that makes it easier for IDEs and things like that to do hinting for what's actually in the Beam bytecode. But if you go and change it, it doesn't actually change what the compiler does, as I found out in the Safeish talk, which was embarrassing.
Yeah, I thought it seemed familiar, but it's not at the front of my brain or the back.
Yeah, it's sort of what the decompiler output would be if you did the Beam, if you actually did the if you decompiled the bytecode. But it's a one-way thing. It doesn't affect what Beam does when you read this file.
Good to know.
And it's optional. If it wasn't there, it would still compile.
Oh, right. Okay.
It's like when you put a debug flag. If you're compiling with debug information, that's the debug information.
All right. Cool. Thanks.
Sorry. Good talk, by the way, Rob.
Oh, thank you.
Yeah.
Any further questions for Rob?
I'll just make a shout out to go and check out the macro module in the Elixir hex docs. There's some really interesting stuff in there, like pre-walk, post-walk, and traverse, if you want to really dig into the AST and do interesting transformations on it.
Yes, there's much more macro madness than available to you if you're interested in just what I've found.
I really liked the metaprogramming book by the McCord one. That was where I that's like, I think, the sort of Bible for also. I mean, if you like books, you can paper ones then or whatever. But that one's got some amazing stuff as well, and you can sort of do like whole pre-processing and pre-compile steps or whatever of the entire module. I can do one walk through it, like Michael was saying. So there are a few different styles of how you can do it. And there's some interesting examples in there as well.
Yeah, it's probably worth, I probably should have mentioned that if I'd read that book, maybe, I wouldn't have had so many problems. But given the fact that my Google searching didn't just result in a whole bunch of people saying refer to page whatever in that book, maybe it's not so clear.
Yeah, I went mad. I mean, I think everyone goes mad when they do macros at the start. And I've done a few things, like even my the stuff that I did for Mavlink, the air vehicle communication protocol stuff. I originally tried doing that as macros, and I eventually wound up just doing code generation, which is pretty hacky, but it was what was actually needed. Like I was literally just printing Elixir code as in strings and then compiling it. That's not like, I mean, macros are awesome, and working in AST is amazing, because like when you look at the AST, it's actually, raw naked Elixir is almost like Lisp. That's what the AST is a lot more like. And that's the fantastic thing Jose did, was he just put this syntactic sugar in a way over, of a more conventional looking language over the top of what's really very Lispy in the AST.
Did it feel like you were learning a new language? That's my recollection of doing macros. It was sort of like being reset to zero.
Yes. Oh, absolutely. Yeah, absolutely. Even though it's like kind of not, because yeah, it's. But yeah, the quoting and unquoting and and that having to have what it means to get have to grab the value that some variable represents by using unquote, etc. is it took some getting used to. I mean, even though the docs sort of do show examples, and if you just copy that, you for very basic macros you'll be fine. But yeah, trying to do it, I guess intuitively is is a little bit fraught.
Quote unquote, quote unquote is basically the red and blue pill of Elixir. It's just like, because really all the time we're actually in AST, the compiler's really reading AST, and macros are producing AST. And so it's really just like, you learn there's this other AST language underneath, and quote unquote's your gateway into slipping in and out of the meta, the meta thing behind your Elixir code.
It might be worth just responding to Scott's comment about I've avoided creating macros up until now, and I'll continue to do so. I think if you're, considering what a macro is useful for and you haven't really used them, I think the first port of call is the using macro. And I think you'll encounter that in Phoenix pretty quickly in the most basic Phoenix apps. And it's good to know how it works, because all it's doing is really injecting a bunch of imports and aliases that are kind of handy, and they're easy to edit, and it's pretty easy to understand, and there's not too much quoting and unquoting going on. So I think, check out the using macro. It's pretty easy if you just want to eliminate some simple boilerplate, and you can look at how Phoenix does that. The other thing that's worth noting is that at the beginning of sort of looking at quote and unquote, I just had no idea how to reason about what that even meant. But I think it's called quote and unquote because it effectively acts like a code version of like a triple quoted string. So it's almost like an interpolated string where you quote the string and then you sort of unquote it with the hash curlies. And you can think of the hash curly as the unquote part, and the strings on the out, or the quotes on the outside being the quote part of the macro. So I think that's not a bad way to think about it if that's confusing.
Yeah. So, sorry.
Sorry, I was gonna say that in the McCord metaprogramming book, the best use of macros I thought was the little DSL language he creates for HTML, because that's really using it like a language. It's like the most unfunctiony use of macros you could have. He actually recreated some of HTML as using begin end blocks and things like that. That was probably one of the most interesting uses. It's because you can actually make a language. In fact, like you said, a lot of Elixir itself is built out of macros. And so, if you're just doing functiony things, then macros might not be it. But when you're actually building, you can actually have, because you can actually have blocks, you can do things like have beginning and ending HTML tags and this sort of stuff, and actually build structures. But sorry, Rob, you go.
I was just going to say, I'm having some difficulty embiggenating this text, but here's an example from an open source library. Here's a def macro that itself calls use on a whole bunch of things, ecto.schema and something else, and it does imports and all sorts of stuff. So this is the using is kind of the thing, as Josh said, you'll encounter, this particular one doesn't go too crazy, but it's basically setting up a whole bunch of things for you, and yes, using inside of using use inside of using is fine. So
I think if you look at the Phoenix using macros, they're pretty straightforward. And they're pretty easy to get your head around. There's no quoting. So check those out. Thanks, Rob. Great talk. I'm really loving the live book Prezzo.
Yeah, it's good. And I did use a new feature right down the bottom. So this is Inline Mermaid.
Nice.
So yeah, it's not an
What?
image. Yeah.
It's out of control.
Yeah, so it's pretty cool.
What else can you do with that? Is there any other secret live view tricks on that?
Oh, well, I mean, there's all the Kino stuff, charts, plotting, sort of doing asynchronous kind of things, and then the basics of live book are collaborative. So if I was running this somewhere, we could we could all collaborate on this. Like if we spun this up on fly.io and everyone had the password, we could collaborate together.